Hello, everyone. Welcome back on our YouTube channel. My name is Hans-Jürgen Schönig, and today's topic is speeding up great index. So, brief thing about us. My name is, as I said, Hans-Jürgen Schönig. I'm the CEO at CYBERTEC, and I'm senior Postgres database consultant with more than 20 years of experience. And I'm the author of various books on Postgres. A brief introduction about CYBERTEC. We are a worldwide company providing services and support for Postgres. So let's get the show started. Great index, speed matters. I guess each of you who is following this channel closely has already created some kind of index. And we often get the question, how can one speed up index creation? And this is exactly what we're going to look at in this video. So the first thing I want to point out is that index creation is expensive. So if you have a really large table, it can take minutes and hours even to create a large index. So definitely we have to do some tuning. And I explicitly want to point out that in this video, we're only going to cover B-tree indexes. So what I'm showing you is especially true for B-tree indexes, but of course, there are also other indexes in Postgres you might want to use. So keep in mind that we're explicitly focusing on B-tree indexes here. So in order to create an index, the first thing we have to do is to create some sample data. And to facilitate that, I have written a small stored procedure called insert data. As you can see in the first line, I've created a table containing just one column. And what this procedure does is basically it takes one input parameter, and then it's going to create the loop and insert 1 million rows into this table each. And what we're using here is simply a set of random values. So just to make sure that the data is not sorted or anything which might impact performance. So bear in mind that we're using 500 million rows of random data here. So once we've called this procedure, it's going to take some time to just populate the data. What we're going to see here is a table that's going to contain 21 gigabytes of data. So it's a reasonably big data set, but it's not huge either. So, but it's just a little bit of data which already needs some disk I/O, etc. So let's see what happens. For a couple of years, Postgres has supported parallel index creation, right? So by default, if you're creating a sufficiently large index, what Postgres is going to do is it's going to use worker processes to create this index in parallel. And the parameter to control this is called max parallel maintenance workers. As you can see, the default value is 2. So by default, it's going to use 2 worker processes to create the index. In my case here, I've set this variable to 0 so that we can get started with single core performance and then see how things change as soon as we move on to multiple cores. So let's take a look. I've run this benchmark on my i5. So this is certainly not cutting edge hardware, but it's totally sufficient to prove the point. So when I create this simple index on this numeric column, it's going to take something like 17 minutes, which is basically quite a long time. So single core performance here is going to be 17 minutes on this machine. Okay. As I've stated already, Postgres can use multiple cores to create an index. So if I set back this max parallel maintenance workers to 2, so to the default value, what we see here is that the index creation is significantly faster. So now what we're seeing here is 11 minutes versus 17 minutes. So we got a whopping 6 minutes improvement. What is important to note here is that the increase in performance, if you add additional cores, is not linear. So what we see here is that we are faster than before, but it's not half the time or a third of the time or so. So it's 6 minutes. It's faster, but it's not like that you can throw a million cores at the problem and just expect things to be done in no time. That's certainly not the case. So if we try this same thing with 4 cores, so if we tell the table that we want 4 parallel workers and then set this max parallel maintenance workers to 4, we got to adjust both parameters to do that. What we're going to see here is that we are already at 9 minutes. So by throwing 4 additional cores at the problem, we basically managed to reduce the creation time from 17 all the way to 9 minutes, which is already quite a significant improvement here. So, but so far we've only covered the CPU side of the problem, right? So create index has to sort the data in order to create this index structure, and the memory parameter governing this sort process is called maintenance workmem. The trouble is that the default value is really low. So what I've done here is I set maintenance workmem to 4 gigabytes. So I've increased this parameter significantly. And what we see here is basically that we gained, again, roughly 1.5 minutes by just adding more memory to this scenario, which is, of course, quite beneficial. So one of the important takeaways is that additional memory is certainly extremely beneficial to index creation. So what you can see here is that we've shaved off 1.5 minutes of this process, which is already a nice thing. And with all those cores and with all this memory, we basically already managed to more than double the speed of this process. So far, what we did was we added memory to the scenario. We added CPUs to the scenario. So the logical next step is to tweak I/O, because if you're building a large index, there's a lot of I/O going on the background, and I got the suspicion that in my setup, I/O is an issue. So let's tweak I/O. One way to do it is to increase checkpoint distances, right? So when Postgres writes to disk, occasionally it has to do a checkpoint. So Postgres has to force data to really go to disk, and this is exactly what happens in a checkpoint. And if you want to increase performance, what you can do is you can basically just increase this checkpoint size and hopefully gain some speed. But let's do a bit more. In my scenario, what I've done here is I've added 2 more SSDs. So one SSD is going to handle the final index. One additional SSD is going to handle the sort process, and then we have this standard SSD in our system, which is just going to handle the raw data and the transaction log. So what I did here was I added 2 more disks to the system in order to create the index a bit faster. Okay. So 6 minutes 50. So we gained roughly 1 minute here. So less than a minute basically by creating this index on the separate table space. So as you can see, I/O did make a difference, but we are already quite on the edge of what is possible and what is not. So final result here is 6 minutes and 48 on my machine. But if you remember closely what I did at the beginning, what you witnessed is that I explicitly used a numeric column for this demo, and the reason is numeric is quite expensive. Okay, so numeric is one of the more expensive data types, so it creates a very nice opportunity to show something. So what you've seen here is the results up to now. So we started with 1,000 seconds, then we added CPU cores, which gave us 534 seconds. Then we added memory, which basically led us to 448. Then we added disks, etc. But let's take a closer look at the last bar. It says indexing integer instead of numeric. So if we had created the same table using integers instead of numeric, the entire process would be almost twice as fast. So as you can see, the data type basically helps us to move from 408 to 231, which is a major, major improvement. Okay, so what I'm trying to point out here is that, of course, you can tune this index creation, you can add CPU, you can add memory, you can add disk, but still you have to make sure that your data types are what you want, etc., etc. And what is also important to note here is that the increase in performance is certainly not linear. Okay, so conclusion: add more cores, add memory, obviously. Make sure that your I/O system is performing properly, and bear in mind that index creation heavily depends on the data type you're using. And of course, there is no magic fix to this, so you cannot just add infinite amounts of hardware and expect speed to go to improve infinitely. So that's certainly not the case. So if you like this program, feel free to send me an email. Certainly follow us on Twitter, like us on Facebook, and please make sure that you subscribe to our channel, ring the bell, and if you want to watch something right now, check out my video about vacuum, which is linked in the description below, and looking forward to seeing you again on this channel. So thank you very much on behalf of CYBERTEC. So have a nice day.